When people say something's impossible, everything's been done, that just means everything has not been done. They just don't know.
They say if we build it, they will come. It's nice to have the ability to start small and to grow as the demand requires. Now we're able to build in a way that allows us to scale if what we've built is popular.
We are moving into AI-driven era where AI takes care of higher order activities.
Today's tools are allowing people to execute if they have the grit and determination.
People build what they can imagine.
Please welcome Amazon Web Services Vice President, Agentic AI, Swami Sivasubramanian.
Hello, everyone. Welcome. I'm excited to have you all here today. Software is changing. Since the early days of computers, think about it. We have codified logic and behavior into applications. We have spent decades into finding ways to do this more and more effectively. We have built higher-level programming languages. We have built software frameworks. And we have built dev tools that make these writing software faster, more secure, and more reliable. But with AI, things are a lot different now. Knowledge has become embedded directly into these models, making them extremely powerful. They have moved from simple mathematical regressions to processing, synthesizing, and acting similar to expert humans. These models fundamentally change how we build applications. The latest models take this to the next level with their ability to reason and make it a programmable resource. We have gone from explicitly hand-wiring each step and codifying instructions to leveraging models that can decide for themselves the outputs and the intermediate steps to achieve it dynamically at runtime. Systems can now interact in more than code or plain language, but they can leverage tools, data sources, and many more. And they can figure out what tools it needs to do to use to accomplish a task. This trait of reasoning allows apps to be successful over a much broader domain and work autonomously for a longer period of time. All of this innovation brings forward the most impactful change we have seen since the dawn of internet, AI agents. What are AI agents? These are the autonomous software systems that leverage AI to reason, plan, and adapt in pursuit of user-defined inputs, completing tasks on behalf of humans or other systems, such as research, paying bills, or managing enterprise applications. Agents can also sense and interact with the digital environment, converting higher-level objectives into executable steps and continuously learning over time and improving their efficiency over time. With agents come a shift to service as software, where autonomous systems dynamically deliver these services rather than requiring users to interact with static apps. Agents are a tectonic change in a few dimensions. They are a shift in the way software is built and how software is deployed and operated. And 3, it changes how software interacts with the world and how we interact with software. And making that possible involves building on the foundations of today, In fact, in a world with agents, they have become more important than ever. Things like security, right-sizing access control and permissions, data foundations that enable the right data to be used at the right time, and the infrastructure that offers the right price performance. We are focused on making our agentic AI vision accessible to every organization by combining rapid innovation with a strong foundation of security, reliability, and operational excellence. Our approach accelerates progress by building on proven principles while embracing these new possibilities, creating systems that can adapt as models evolve, new capabilities emerge, and your use cases expand. Today, I'm excited to share how we are bringing this vision to life with new capabilities that address the fundamental aspects of building and deploying agents at scale. To do this, we need a few major innovations to enable this agentic future that we will unpack in this keynote. We see a few key areas. First, agents are powered by inference, meaning access to the best foundational models and capabilities to support them is critical. Next, for defining these new agentic architectures, developers need tools and frameworks that help them build these agents. Then, deployment and operations in production still remain a massive blocker for realizing the value of agents. This requires a whole new set of services that are built for these unique challenges. And lastly, agents need better mechanisms for discovery and procurement. Now, let's take a look at how we can resolve these challenges, starting with inference. Amazon Bedrock is the easiest way to build and scale any type of AI applications on AWS. Bedrock offers a broad choice of leading models. They enable you to customize your AI apps with data using knowledge bases, apply guardrails for responsible and ethical AI checks, optimize for your use case across cost, latency, and accuracy with distillation and prompt routing, and to build and orchestrate agents, all with AWS security, privacy, and responsible AI built in. Bedrock makes it really easy to use the latest and greatest foundational models with a consistent API in a fully serverless fashion. Why do we offer so many models? It's because we know there is no one model that's best for every use case out there. And Bedrock's model catalog has expanded into completely new modalities like video generation from Luma, models specialized for agentic workloads from Rider, and video understanding models from 12 Labs, which we just made generally available earlier this morning. The world of foundational models moves incredibly quickly. This makes it all the more important to choose a provider that matches the agility and space around us. Take DeepSeek, for example. It took us only 10 days when DeepSeek was released with their open source R1 model to offering it in Bedrock as the first major provider. And then again, we were the first to have a serverless, fully managed offering. At this time last year, we offered fully managed models from 7 leading providers, and today we are nearly a double with 12 providers. We are also investing in programs to help accelerate your AI journey, like partnering with Meta to supercharge generative AI innovation with Llama models. Here, AWS will provide up to $200K in AWS credits for selected startups, with AWS and Meta providing dedicated technical support. Today, companies of every shape and size are using Bedrock to build Gen AI apps and transform their business. With model accuracy continuing to improve, it's no wonder we have seen so many of you build AI applications on Bedrock. Another big area of investment is in Amazon Nova, our own set of frontier models. To tell us more, please join me in welcoming Rohit Prasad, SVP and Head Scientist at Amazon AGI.
Thank you, Swami. It's great to be here. In December, we introduced Amazon Nova, a family of foundation models that do everything from understand text, image, and video content to generate images and videos on demand. And since then, we have continued to expand our model lineup. Nova Act for building intelligent agents that can take actions on browser. With Nova Sonic, we have made it much easier for developers to build voice applications and agents that have human-like conversational abilities. We've also introduced Nova Premier, which is our most advanced multimodal model and also serves as the teacher model for distillation. 8 models in just over 6 months, and that's only the beginning. We are constantly enhancing these models with new capabilities. Just today, we expanded Nova Sonic's language support beyond English and Spanish to include French, German, and Italian. And in fact, we just launched a new capability in Nova Canvas, which we call Virtual Try-On. We've all been there, debating between that shirt we'll wear or wondering what would this coffee table look like in our living room. Nova Canvas gives retailers a powerful way to help shoppers see what products will look like in real life, seamlessly blending them into their environment and making shopping experiences that far easier and more personal. You can experience it yourself on nova.amazon.com, and don't miss our demo booth here today. Over 10,000 customers are already using Amazon Nova, from marketing giants like Dentsu to tech leaders like Infosys, Blue Origin, Coinbase, and Robinhood, and also even innovative startups like Crescendo AI. What truly matters is how these models drive real-world impact. For example, AppFolio is using Nova Pro to power their intelligent real estate assistants to help real estate agents respond faster and serve clients better. Another startup, Rubberband, is using Nova Reel to create video storyboards more quickly and creatively. These represent real-world business outcomes, better experiences, significant cost savings, and faster processing times. So what have we learned in the past 6 months? Foundation models can deliver impressive accuracy out of the box, getting you 80% of the way with minimal prompt engineering and some retrieval augmented generation, or what we call RAG. But for business-critical applications, 80% is not good enough. Every percentage point matters to earn customers' trust, which typically happens at 90% plus accuracy. Reaching this level requires models equipped with your knowledge, running at your target cost and latency, while staying updated with your evolving context of your application. That simply cannot be achieved by just bolting RAG on top of your foundation models. That's why today we are excited to announce comprehensive customization for Nova models on SageMaker AI that covers all stages from pre-training to post-training. You can now customize Nova Micro, Lite, and Pro using various recipes that match your specific needs. For example, with a few thousand examples of training sets with input-output pairs, you can do fine-tuning to update a subset of model parameters. This is called parameter-efficient fine-tuning. And if you have tens of thousands of training examples, you can update all the parameters. Similarly, you can use direct preference optimization or proximal policy optimization to align the models to your use cases. We are also providing recipes for continued pre-training to impart foundational knowledge in your domain and model distillation to train smaller student models. These recipes run on SageMaker AI, either in training jobs or a new setup of SageMaker Hyperpod, which simplifies large-scale customization and eliminates the complexity of managing numerous steps in your multiple EC2 accelerators. To me, this represents the industry's most comprehensive customization capabilities for any proprietary model family today. And I'm super excited to announce that we now have on-demand inference for Nova models, which can be run with custom models that are using parameter-efficient fine-tuning, which delivers major cost savings for use cases. What has pleasantly surprised me is how such customization isn't just improving accuracy, but unlocking entirely new use cases for generative AI. Let me share an example. We are working with MIT researchers who are using supervised fine-tuning to transform metamaterials research, which is about designing synthetic materials for use cases such as robotics, aerospace, and even packaging applications. Their customized models takes an engineer's input, design goal, it could be an image as well, and prototype code as input, and then output simulation-ready Python code or structured material property predictions. The results speak for themselves. They've achieved a 95% reduction in property prediction errors. This, to me, unlocks an easy-to-use research assistant in a highly specialized research area. Our second learning is agents need a leap in accuracy and reliability. Imagine having an agent that's always 90% accurate. Sounds great, unless it's unpredictable. Like a brilliant and inconsistent colleague, it may be 90% accurate on a specific task today and only 70% accurate tomorrow. That's ultimately unreliable. To deliver improved reliability, a few months back, we started the research preview of NOAA Act, which enables developers to build agents that take action in web browsers, all through a simple SDK that is available on our NOAA website. Using a browser seems effortless to us, but it requires constant judgment, interpreting what's on screen while scrolling, clicking, and completing forms. These actions, while simple for you and I, remain challenging for the AI. That's why we decided we developed NOAA Act with specialized training using millions of user interface interactions. By layering in advanced reasoning capabilities, we were able to make NOAA Act more resilient to website changes and recover from its own errors. During research preview, we have worked with thousands of developers to improve NOAA Act. We have improved the underlying model with fine-tuning and reinforcement learning. With these improvements, we are seeing end-to-end task completion rates above 90% on early enterprise use cases. And now we are excited to work with AWS customers on building production-grade browser agents. These agents can be deployed with high reliability for end-to-end tasks alongside enhanced security and access controls that are available on AWS. Let me show you NOAA Act in action with a real customer example. Millions of people in the US face hunger, and every day thousands need to apply for food assistance programs. But it can be extremely time-consuming to do so. Alvi Health worked with Rackspace to automate this process with NOAA Act. Let me show you how. We start by creating a simple NOAA Act script where we instruct the Act model how to approach the task, the same way we might describe it to a person. Then, NOAA Act agents get to work in the browser, analyzing what it sees and what action it needs to take to complete the task. We don't have to tell it anything about the layout of the site or the format of the application because it navigates the web page the same way a person like you and I would. Now, it looks for the best path forward to execute the task. The agent then goes step by step through every question, which this application includes, unfortunately, hundreds of questions. What makes NOAA Act truly powerful is its ability to navigate hundreds of different websites, regardless of how differently they are designed, using the same set of instructions. All you need to tell NOAA is where to begin. For Alvi Health, this means they can easily scale their services across every state that offers a web-based food assistance application. Alvi Health is just one example. Customers are already using NOAA Act in exciting ways. This includes Alexa Plus, Automation Anywhere, Navan, and Tyler Technologies. NOAA Act brings us a step closer to artificial general intelligence, where the AI can accomplish the same task you and I do every day on a computer. I encourage you to try it out on the NOAA website. To recap, we are excited to bring a new level of customization to NOAA to build your business-critical applications. And with NOAA Act, we are taking a big step forward so that you can deploy your reliable browser agents on AWS. This work really reflects our mission, making the complex incredibly simple for our customers. We are excited to see what you build with them. Thank you, and back to you, Swami.
All right. Thank you, Rohit. Now we have spent a lot of time on models so far. And that's important because models are at the center of all this excitement. But there are a few big areas where agentic applications differ from traditional software. First is decomposition. Agents take higher level objectives as inputs, and they decompose them into plans and any required code necessary to solve the problem. Unlike traditional static apps, where they will execute step by step, agents are different. They are dynamic, and they change during runtime. Second is self-reflection. Rather than running through their instructions from start to finish like a pipeline, they self-reflect and until they have reached a desired goal, changing their tactics as and when needed. And third is action and tool use. Whether that's performing actions in other systems like making API requests or being able to access data and even call other agents like NOAA Act, that may be specialized to do particular tasks that is necessary for achieving the overall goal. So what does this mean for how we build agentic software? Well, to put simply, agents demand new tools and frameworks for builders. Many of our customers have built and experimented with agents using Bedrock, and we have learned a lot from your feedback. And one thing we have learned is that you want more control and the ability to more easily use open frameworks with AWS. These open frameworks take the heavy lifting out of orchestrating these agentic applications. We have seen a lot of momentum around frameworks like Crew AI, LangGraph, and Llama Index. We have also released TransAgent SDK, an open source framework that delivers a simple, modern-driven approach to building agents. Compared with other frameworks that require developers to define their complex workflows for their agents, Trans is different. It simplifies agent development by embracing the capabilities of the state-of-the-art reasoning models to plan, change their thoughts, call tools, and self-reflect. TransAgent is provider agnostic, while also having native tools, MCP servers, and integration with AWS services out of the box. And just yesterday, we released TransAgent 1.0, which brings new capabilities for building multi-agent systems, including A2A support, data persistence for agent conversation, and multi-agent workflows. We have seen strong support for TransAgents from the model provider community. Anthropic, Cohere, Meta, Mistral, 12 Labs, Stability, and Writer have made contributions which enable more nuanced support for their model APIs to be used by a TransAgent. And it's not just about frameworks. You need these agents to be interoperable, both with the tools they use as well as other agents. Here is where emerging standards like MCP and A2A come in. They are tackling this challenge with broad adoption from industry leaders like Anthropic, Meta, and Google. These protocols help us connect agentic apps or models to data sources, tools, memory banks, and more. Instead of having every app developer write connections for each destination, the provider writes an MCP for their own interface, and it allows agents to interact with it. At AWS, we are really leaning in here. We are on the steering committee for both MCP and A2A projects, bringing our decades of expertise in distributed systems at Amazon to improve these protocols. For MCP, several core components in the latest spec were designed and contributed by AWS. Now, despite all of these open source frameworks and protocols, getting agents to production is still too hard. This is because of the dynamic and autonomous nature of agents and the effect it has on how you build and operate them. So we took a look at what you need to be able to deploy agents to production. First, there is figuring out how to securely execute and scale the agent code. This involves building, configuring, and scaling a runtime and execution environment that can handle all the dynamic agent code and workloads. And it's not just about scaling compute. You also need to maintain guarantees around security and isolation so that data from one instance of the agent does not leak to another. Then you need a way for agents to remember their past interactions and learn to improve over time, allowing them to be truly personalized. Storing memory for agents is not as simple as storing a traditional app state into a database. It requires supporting not just high-performance logging of short-term activities, but also mapping these extremely long contexts to higher-level concepts that the agents learn over time. Next is enabling agents to interact with true autonomy on behalf of user and systems. Doing this the right way requires identity and access control for our agents, tools, data sources, and beyond. Fine-grained access controls enable agents to only access the systems and data sources you allow them to do so, such as specific API call for actions, subset of tables in a database, and more. Next, agents are as valuable as the actions they can take. To help with this, they need to be able to use a number of common agentic tools. One example of this is being able to use code to perform tasks that foundational models haven't been pre-programmed to do, like complex math calculations. Doing this requires generating and executing code in a secure manner in a way that does not interfere with the original agent code itself, or allowing the agent to interact with common interfaces. Here, a use of a browser changes what's possible, enabling agents to take action in the digital world, whether that's consuming data from the web or taking actions on a website by filling a form. But there are a whole host of common tools agents need to discover and connect to. This includes tools for taking actions or just for consuming data, whether that's sourced within an organization or outside the organization. Then there is the challenge for agents discovering and understanding which of these tools they need to use for their task at a given moment. And finally, we need deep auditability and understanding of the actions our agents are taking. Complex, multi-step agentic workflows are even more challenging to debug than traditional software. If something fails, it is absolutely critical to understand why, not just where they fail. Here, we need telemetry and observability for every interaction in their workflow, including the intermediate steps. As you can see, today there are a bunch of missing pieces that make it really difficult from moving from POCs that are sitting in laptops to agents in real-world production use cases. And all of this work to tie your agent together for a single combination of one framework, one model, and one set of tools doesn't stop there. You need to do this all over again when the business use case changes, or you want to use a different model, or new frameworks come up. All this muck is slowing down customers and preventing them from getting agents into production quickly. So we took a look at this entire end-to-end problem and asked ourselves, how could we make this faster and easier for you? That's why today I am excited to announce Amazon Bedrock AgentCore, a set of services to deploy and operate capable agents securely at scale using any framework or model. AgentCore is a step change for moving your agents from POC to production with scale, reliability, and security that are critical for real-world deployment. It provides tools and capabilities to make agents more effective and more capable, purpose-built infra to securely scale agents, and provide the controls to enable you to build trustworthy agents. AgentCore services can be used together or independently, giving developers the ultimate flexibility they need. Let me show you with an example how AgentCore addresses each of these before I dive into them. To begin with, first, there is the ability to securely scale agents. AgentCore Runtime is a secure serverless runtime purpose-built for deploying and scaling dynamic AI agents and tools, regardless of frameworks, protocol, or model choice. Developers can securely and reliably run any type of agents, including multimodal, real-time, or long-running agents, with workloads running up to 8 hours, the longest in the industry. Runtime is highly reliable with checkpointing and recovery capabilities built in to support graceful recovery in case of unexpected interruptions and failures. And it can scale up to thousands of agent invocation sessions in just seconds. Runtime is secure by design with built-in identity controls, and it is the only runtime available today with complete session isolation, not just like a process isolation, providing dedicated compute environments per session with complete memory isolation to help prevent data leaks across agents. Second is handling full management of memory systems with AgentCore Memory. AgentCore Memory makes it easy for developers to build context-aware agents. Memory provides industry-leading accuracy, along with support for both short-term memory for multi-turn conversations and long-term memory that persists across user sessions, with the ability to share memory stores across collaborating agents. Now developers can just focus on building intelligent agents rather than managing these memory systems. With this memory service, there is a lot of clever management of how memories are formed and managed automatically under the hood. Let me show you. As humans, we have a short-term memory that is really fine-grained and kept in relatively small size, storing data like what I had for breakfast this morning. Then we have long-term memory, which is a lot less granular, but is efficient, mapping higher-level concepts all together like what my favorite foods are. Over time, the brain does a lot of work to take these frequent short-term memories and encode them into longer-term memories. And over many years, the brain constantly rewires their neurons, even for those long-term memories, causing them to get recompacted over and over again, preserving what's important in an efficient way. Memory service works very similarly. This is all done automatically for you under the cover with a single memory endpoint. Next, agents need to securely access other agents and tools. This is where with AgentCore Identity, we provide secure, centralized access management for AI agents, enabling seamless integration with AWS resources and third-party services. We simplify secure and delegated access for agents by providing each agent with a unique identity. This distinct identity enables agents to operate with appropriate security controls and proper authorization across different systems like GitHub or Salesforce. AgentCore works with your existing identity providers, including Amazon Cognito, Okta, Microsoft Entra ID, and others, so there is no need to migrate your users or rebuild your authentication flows. For agent builders, we simplify access to third-party services by securely managing API keys and OAuth client credentials. Next, we build tools that are critical for many agentic workloads. For writing code to enhance agents' accuracy and expanding their ability to solve complex end-to-end tasks, we have built AgentCore Code Interpreter. Code Interpreter tool enables AI agents to write and execute code securely in their own sandbox environment. It comes with pre-built runtimes for multiple languages and advanced features such as large file support and internet access. And developers can customize their environments with specific instance types and session properties to help meet their security requirements. The second agentic tool is AgentCore Browser Tool. This provides a fast, secure, scalable, cloud-based browser to enable AI agents to interact with websites at scale. While most browser tools out there are tied to a specific model, such as Sonnet 3.5, 3.7, or OpenAI's computer use preview, AgentCore Browser Tool is model agnostic. It includes enterprise-grade security features, including VM-level isolation and federated identity integration, critical for carrying out tasks that require embedding secrets natively. Then agents need to call all sorts of tools and data sources to execute their workflow. And for this, we have AgentCore Gateway. Gateway provides an easy and secure way for developers to build, deploy, discover, and connect to tools and agents at scale. Developers can convert their existing APIs, Lambda functions, and existing services into MCP-compatible tools and make them available to agents through Gateway endpoints with just a few lines of code. Gateway even provides one-click integration with several popular tools such as Salesforce, Slack, Jira, Asana, and Zendesk. For input types, Gateway supports OpenAPI, Smithy, and AWS Lambda. And as your tool collection grows, agents can find and use the right tools faster through built-in semantic search capabilities. And because you need a secure way to do this, it automatically connects into our identity service. Finally, AgentCore Observability helps developers trace, debug, and monitor agent performance. It offers detailed visualizations of each step in the agent workflow, enabling developers to deeply inspect into an agent's execution path, audit all their intermediate outputs, and debug performance bottlenecks and failures. Observability gives developers real-time visibility into agent operational performance through built-in dashboards by CloudWatch, and telemetry for key metrics such as session count, latency, duration, and error rates. AgentCore emits telemetry data in open telemetry format so that enabling customers to easily integrate with their existing monitoring and observability stack. Okay, now we have all of these primitives. Let's take a look at an example of AgentCore in action. For this example, we are going to build an agentic loan processor, one that accelerates risk analysis based on credit and other data before passing to a human to finalize. Our proof of concept already uses the Crew AI framework to compose a crew of 3 agents running across multiple hosting providers, not just on Bedrock or AWS. First is an intake agent that can organize loan application data. Second is a credit agent that can analyze creditworthiness and calculate risk metrics. And for third, there is an underwriting agent, which takes all this analysis and writes a recommendation that is then passed off for a human to review. Now, let's use AgentCore to make our proof of concept ready for production. First, we will add memory. When we add memory to our agent, we simply give the memory group a name, description, and decide how long we want these memories to be stored, and add a memory strategy to help the model sort short-term memories into useful long-term memory categories. With this configured, our agent can now remember details from previous conversations and provide a very personalized experience. Next, we want our agents to utilize tools from across the organization. So we are going to add an AgentCore Gateway. Here, we will set the role for the agent to use and attach our authorization method, either using AgentCore Identity or an externally managed identity provider. Then we are going to add targets to the gateway. These are the specific resources we want the agent to be able to use. You will add a target for Lambda so that we can poll for updated payment data stored in Dynamo, or an S3 target to access historic loan documents we may have on file. and a gateway target for an external API that will enable the agents to do things like income verification. Next, we want the agent to handle any calculations the human underwriter might have. So for that, we are going to add AgentCore Code Interpreter. Now the underwriter agent will be able to perform analysis such as adjusting the weighting of the borrower's debt-to-income ratio. And then the agent can quickly create and execute the code that is needed to do this calculation. And now we are ready to deploy, where we will use the AgentCore Runtime secure serverless environment that can handle both real-time and long-running agent workloads, automatically scaling to meet demand. We just create a runtime instance, specify the endpoint, which in this case is a Python file for our agent. And runtime handles all the infrastructure, scaling, and security. Finally, we can use AgentCore Observability to monitor how our agent is performing and get its insights into the health and usage. These dashboards enable us to debug problems across the agent's process. Like if our loan processor is taking a long time to calculate risk, or to understand which edge cases are causing application ingestion to fail. And that's it. We have a fully production-ready agent deployed, secured, metered, and scaled, ready to help us transform our business, all with the freedom to innovate with models, frameworks, and data from anywhere. So this is AgentCore, a set of modular services that allows you to mix and match with everything you need for getting agents to production. And it represents a step function change in what is possible for AI agents. Now, building specialized AI agents in-house requires expertise across multiple domains, not just from large language models, but also with specific business functions. No organization can be an expert in everything, nor should they be. And just as today's software ecosystem thrives on third-party APIs, tomorrow's AI agents will need to integrate specialized capabilities from across organizations, providers, and systems. What is needed is a trusted source that brings together builders and buyers of AI capabilities in a centralized, secure, and governable way. So we asked ourselves, how could we enable this? Today, I'm excited to announce AI agents and tools in AWS Marketplace. Already, AWS Marketplace is your trusted source for discovering and deploying AI agent solutions from our expert AWS partner community and the world's leading AI providers. With this launch, you have access to a centralized catalog of AI agents, tools, solutions, and services from popular vendors. So you can benefit from a seamless API-based deployment using MCP and A2A. And deploy these pre-built agents and tools with AgentCore Runtime and Gateway. With this launch, AWS Marketplace now includes solutions and expertise from AWS partners like Anthropic, Salesforce, Deloitte, and others across areas like pre-built agents, agent tools including MCP servers, knowledge bases, guardrails, and many more, and professional services to help you develop and implement an AI strategy, and both agent development solutions for building your own agents and software solutions with embedded agentic capabilities. Together, AgentCore and AWS Marketplace enable more than the sum of their parts. Customers can deploy and scale AgentCore native pre-built agents and tools from Marketplace on AgentCore Runtime. And with just a few lines of code, you can allow your agents to securely connect to ready-to-integrate solutions from Marketplace with AgentCore Gateway. Now you can test and run AI agent solutions from a range of vendors, then quickly push to production and scale. Now, to tell us more about a customer that is building agents on AWS as part of their AI journey, please welcome Ashok Srivastava, Senior Vice President and Chief Data Officer at Intuit.
Thank you, Swami. It's incredible to be here with all of you here in New York City. Since I was a child, I've come to the city so often, and I tell you, every time I come here, it sparks my imagination. And it always makes me feel that anything is possible. So, if anything is possible, the question that we have to answer is, what are we going to build? What are you going to build if you could build anything for your customers? We now have, as a society, some of the most advanced technologies available in history. What should we do together to make the world a better place? That's the question that I'd like you to ponder as we go through this presentation. So at Intuit, we create products that can help power prosperity around the world. It's why I work there. We've got an unprecedented opportunity to create experiences for our customers that help them make better financial decisions. You know, as a former small business owner, I can tell you that every single financial decision that you make is critical to the success of your business. So we take our mission very seriously. I tell you, it's so inspiring to see so many people, thousands of people galvanized on this single mission of powering prosperity around the world. We've declared some bold goals here that we'll achieve by 2030 that enable us to be the best in class and also a high-growth company. We've reinvented ourselves so many times over the last 40 years. So back in the 1980s, Scott Cook, our founder, started this company at literally the kitchen table at his home, where he was watching his wife balance the checkbook. And he thought to himself, is there something that we could do to actually make this a better experience? That was the question. And that was the foundation, the founding of Intuit. We have reinvented ourselves so many times over the last 4 decades. The era of DOS, Windows, the web, cloud, and now in 2019, the era of artificial intelligence at Intuit. We created GenOS, the generative AI operating system that now thousands of developers around Intuit use to build agents at scale. 2 weeks ago, we formally launched our agent experiences, and I'm going to show you that in a few moments, and you'll get a glimpse of the power of this technology in the hands of real customers. So I'd like to give you an idea of the scale of our AI and data systems. Back when we started this journey, we had a small, nascent team of AI scientists and developers, and we started to make the investments to build a powerful AI platform, a powerful, high-throughput data platform that could really generate clean data at scale for our developers. It was an incredibly exciting time. And today, we have AI and data systems that are generating 60 billion machine learning predictions per day. We have this based on 95 petabytes of data and with over 500,000 attributes per customer. So that gives you an idea of the scale of the systems that we're building and operating today. And we have over 1,000 AI patents in this space. So these platform advancements were built on AWS, and you know, I want to say the partnership with AWS has been absolutely fantastic. The AWS team and their technologies have been such an instrumental and important part of our journey. I just want to take a moment and thank them for the amazing partnership that we've had over the last many years, and also for what's to come, because what's to come is so incredibly exciting. So this is a high-level architecture of how we run on AWS. So you'll see at the bottom layer, we have the foundational technologies from AWS. This is SageMaker, Bedrock, Aurora, MSK. These are the foundational capabilities on which we built a lot of our own capabilities. Our data capabilities, such as stream processing, batch processing, the data lake, an event bus, vector database, all of these things are built on top of AWS. And this is where GenOS comes in. GenOS allows us to do orchestration with tools, enables context and memory, observability, and it has Gen Runtime, which has guardrails built in so that those LLMs do the right thing. And you'll notice at the right-hand side of the screen, we have human experts, because we understand that artificial intelligence is amazing, but we also know that human intelligence is unparalleled. And when you bring these two things together, magic happens. And that's what I'm so excited about to talk with you today. So let's look a little bit more at GenOS. GenOS powers our agentic experiences, and it has 4 key components. There's the large language models, and this is what does the conversational capabilities, the reasoning capabilities. Gen Studio, which is the interface between our engineers and those large language models. Then we have Gen Runtime, which we created way back in 2023, knowing that agents were on the horizon. And Gen Runtime does the following. It actually does orchestration with tools, and it turns out to be the brains of the AI system, of these agents. Fantastic capability. And so how do we interact with the customers directly? That happens through GenUX. This is part of the operating system that provides the user interface for our agentic experiences. So let's go back to that question that I originally posed at the beginning of this talk. Given all of these amazing tools and technologies, how are we going to choose the problems to work on? We decide based on deep research with our customers. We interview them through a process we call Follow Me Homes, where we literally go to our customers and we watch how they're using our software, how they're using the other tools that they have in their own context. But we also have a tremendous amount of data, and that data is used by our analytics teams to really understand at scale how people are using our products. And so we define customer problems. We know that customers want to get more customers of their own. They want to grow and manage them. They want to get paid, and they want to pay their bills fast, and they want to get access to capital. But you know what? The most important thing that they want is work done for them. They want done-for-you experiences, and that's exactly what our agents provide. So I'm now going to take you through how our agentic technologies help power prosperities for our customers. You're going to see 4 agents, and they're going to be working together simultaneously to help a small business owner. The customer agent to get customers, the finance agent to improve their cash flow, the payments agent to get paid, and the accounting agent to do their books. So it's the ingenuity of thousands of developers combined with AI and data that create these agents, and I have to say, it's a privilege to be here representing all of them. So here we have a small business owner. The customer and the agent enables her to select a hot lead to get started on an estimate, automatically generates the estimate, the customer signs the contract. The finance agent flags the cash flow is down to 13%, suggests she apply for a line of credit. She agrees, bringing her cash flow up to 20%. The payments agent automatically drafts an invoice. We know that customers are getting paid 5 days faster on average, and an overdue invoice is 10% more likely to be paid in full. And then the accounting agent automatically categorizes transactions, and all of this is built on GenOS. So this is the incredible excitement that we have with the agents. I'd like to take you through a little bit more about how to think about what to build. So to deliver real value for customers, build with a purpose. Don't get enamored with the technology. Use AI only where it's necessary. If rules do, use rules. If you need AI, use AI. Measure your ROI, your return on investment, so you know if you're making progress, and empower small teams to move fast. We've found that building paved paths with AWS has accelerated our journey. So fundamentally, we must all build what our customers need, and together we can make the world a better place for everyone. So I'd like to thank you, I'd like to thank Swami and AWS for this amazing partnership. Thank you very much.
All right. Thanks, Ashok. As you can see, agents are already having a big impact. But AI's intelligence is constrained by the data they can access. Traditional data challenges, such as siloed databases, or poor interoperability, or inconsistent governance. These aren't just problems anymore. They are barriers to AI innovation that limit what's possible with these powerful technologies. So how do we bridge this gap between AI potential and data limitations? The answer lies in a fundamental technology that's transforming how these machines understand information. Vectors are the language of AI, capturing context and relationships within data, store memory, retrieve relevant information, and correlate insights across petabytes of data. Vectors will fundamentally change how we use data for every modern business. Agents use vectors for two critical functions. One, for building context from their past interactions. And two, discovering things like similarities across massive data sets, like detecting anomalies in a security footage or finding patterns in medical images. Now, as companies are investing more in knowledgeable AI agents, their vector embeddings expand from millions to billions and many even more. These massive AI data sets aren't just temporary resources anymore. They are the strategic assets that must be preserved long-term to unlock continuous learning, maintain historical context, and support model retraining and fine-tuning. The challenge compounds more when these embedding models are updated. Businesses now must create new vector sets with the latest models, while versioning and storing the previous generations for compliance, auditability, and performance benchmarking. Moreover, AI agents perform best with comprehensive historical context across years of data. But current vector storage options weren't designed for this use case. They are optimized for hot data and high-frequency queries, not long-term, infrequently accessed vector sets that these agents need. This creates a fundamental mismatch. Agents need extensive memory, but today's vector systems assume you need everything fast and frequently. The challenge is compounded because vector indexes can become really large than the original data itself. So we asked ourselves, what if you don't have to choose between scale and cost? What if your storage had a vector search built in? What if you could easily index across all your AI data? These questions led us to one simple answer: Amazon S3 Vectors, which we announced yesterday. This is a huge capability and a new capability for storing, accessing, and searching and querying over vectors natively within S3. And it is the first cloud object store with built-in vector support. Now you can store and search massive vector data sets with the cost-effectiveness, elasticity, and pay-as-you-go model of S3. With S3 vectors, you can access vectors with sub-second query performance, ideal for infrequent query workloads like batch processing and non-real-time agentic apps. S3 Vectors integrates natively with Bedrock knowledge bases, reducing the cost of your RAG, and with Amazon OpenSearch service to create a tiered vector strategy. So that means now you can store your long-term vector data sets in S3 and use the OpenSearch service for workloads that require high query throughput and low latency. This optimizes costs while delivering exceptional query performance as well. S3 Vectors transforms the economics of agentic AI, enabling you to store and query vector embeddings and enabling you to scale up to 90% less cost compared to alternative solutions. No capacity planning, no infra overhead, and you only pay for what you use and benefit from all of the S3 attributes that you know and love. In fact, it is one of the many underlying innovations that is powering the new AgentCore Memory service we just announced. With all these innovations, we make building and deploying agents to production easier than ever. No matter the component or where you are in the life cycle, we have you covered. With new cost-efficient storage and querying of data with S3 Vectors, from the models and application components in Amazon Bedrock, to new customization options in Amazon Nova, to support for open frameworks and interoperability standards, to AgentCore, an entirely new set of 7 powerful services for building and operating agents, to your new place to go for agents and tools in AWS Marketplace. All of these come together to make AWS the best place to build and deploy agents. Now, while models and infra change how organizations build, agentic solutions transform how businesses operate. The true power of agentic AI is in its ability to reshape workflows and human productivity across entire industries. We are making this transformation accessible to more organizations through pre-built agentic solutions. I'm going to dive into a few of these areas, starting with software development. Today, software development is one of the biggest areas where agents are being put to use. This is because the tasks and data from this domain pair really well with the knowledge that is embedded into these foundational models. Oftentimes, the most revolutionary ways of applying new technology is not just to insert them into experiences we already know today, but rather, we need to take a step back and rethink what new applications and experiences can look like with agents. So we went and thought, what are new ways we can reimagine the developer interface? Earlier this week, we announced the preview launch of KIRO. KIRO is a new agentic IDE that helps you from concept to production through a simplified developer experience. By combining the speed and ease of natural language prompting with the discipline of proper software engineering practices, KIRO helps you generate scalable and easy to maintain code that you can deploy to production with confidence. Let me show you how. Traditionally, writing software specs is time-consuming and challenging to keep them up to date over time. This is where KIRO allows you to quickly develop these specs with natural language, which it uses to generate plans, order the set of steps to complete, identify all the dependencies, and link those to the original requirements. KIRO then transforms these specifications from static documents into living, self-documenting sources of truth that evolve over time from initial proof of concept to production code. Next is agent hooks. Hooks are event-driven automation that trigger every time you save, delete, or create a file, or on a manual trigger. Hooks enables you to turn manual, tedious tasks into automated workflows, like automatically updating your tests as soon as you change your code, or refresh the documentation when you add a new API endpoint to your application. Now, we put KIRO in the hands of a few developers to see what it meant to them. Let's take a look.
It's like your coding buddy. I want this to be better, and I feel like it's not performing the way that I want. Can you optimize it, or can you give me ideas of how to fix it?
I use it for the AWS documentation, MCP. It's really hard to have documentation when it comes to like integrating something. You know, I've got an SQS queue to a Lambda function. Do I look at the SQS docs? Do I look at the Lambda docs? I don't know. But MCP draws that together in one place for me.
Sometimes you might have it implement something, and then you want to use that as context to then reprompt it in a different direction. So you could be like, hey, I like how you did it like this, but I want you to do it this way. And having it sort of be creative. And even debugging, like that's something where I could be like, hey, I'm getting this error at the dev server, and then in this other app, I'm getting this issue. Can you help resolve all this stuff? And you can just throw it in the prompt. And it does a really great job of distilling the problem and helping you find a solution.
It lowers the barrier to entry, whether that be you don't even know how to code, you're new to coding, or you're like me and you're just learning a new tech stack. If something doesn't make sense to you, or if you feel like you're asking a silly question, ask anyway.
It's helping me learn how it's coding as it does stuff. I'm actually getting smarter. And then it gives you, again, here's like a whole bunch of implementation, but it might not necessarily do it. It might just give you an idea, and then I'd be like, okay, let's implement it. And then it's like, okay, KIRO's working, we're gonna go do it.
Can I take this?
Yeah.
We are incredibly excited about KIRO and are looking forward to seeing what it means to transform software developers with agents. But we know that there are many developers who really love their existing developer environments. For that, we have Amazon Q Developer, our AI coding assistant that can be easily integrated into your current IDE of choice or used directly from the command line such as CLI. Q handles everything from authoring features, code completion, security scanning, and many more. We are constantly evolving Q Developer, making it increasingly agentic, bringing it to more places by collaborating directly with partners like GitLab, and very soon, IDEs like JetBrains. And we have been listening closely to customer feedback, bringing new features like expanded MCP support, real-time code suggestion across 35+ languages, automated multi-file feature, intelligent code reviews, and many more. We have seen amazing growth in Q Developer, especially Amazon Q CLI, and customers have been using it to build amazing things. In fact, Q CLI processes millions of user interactions and tool calls on a daily basis. Another area we knew we could uniquely help customers is migration and modernization. Modernizing decades-old application and untangling their legacy infrastructure can be a slow, costly process. That's why we built AWS Transform, a migration and modernization agent with 19 years of breakthroughs, challenges, and transformation. We have seen just about everything and took what we have learned and built it into Transform to make modernization as easy as possible across migrations from .NET frameworks, VMware, and mainframe. Let's unpack how Transform can help for each one of these. First is modernizing Windows.NET applications to Linux. Here, Transform can automatically discover incompatibilities, generate a transformation plan, and can refactor the source code on your behalf. Using Transform has helped developers modernize their .NET apps up to 4 times faster and cut the cost of Windows licensing by up to 40% by moving off of Windows. Next is VMware. Transform agents simplify and automate on-prem app discovery, wave planning, and orchestration of the end-to-end migration process. And Transform tackles one of the hardest parts of VMware migration by automatically converting VMware network configurations and firewall rules into AWS network constructs. With this Transform, this is up to 80 times faster. One customer, CSL Behring, has seen a 10 times improvement in application discovery and wave planning, removing thousands of hours of migration time. Our own AWS Professional Services is using AWS Transform in their customer engagements, reducing weeks of work down to 1 hour, and by integrating tools like Cloud Migration Factory, migrating VMs 80% faster. Transform can even assist with modernizing complex mainframe apps, starting with IBM ZOS. Mainframe projects that used to take years can now be completed in months. Since its GA launch in mid-May, AWS Transform has helped customers and partners analyze more than 128 million lines of code since its launch. One customer is Pegasystems, who is compressing this multi-year mainframe modernization project to deliver value in under 90 days. To tell us more about how AWS Transform is helping modernize their business, please welcome Matt Dimich from Thomson Reuters.
Hey everyone, thanks for joining today. Let me start with a quick question. Who's ever worked on a legacy application and felt trapped by technical debt? At Thomson Reuters, we're working across decades of tech evolution, monoliths, microservices, .NET, Java, and more, all of it mission critical. Managing that environment takes time. And for every hour our teams are applying patches, updating libraries, or managing infrastructure, that's time we're not spending delivering value to our customers. If you know Thomson Reuters solely as the legal research or tax software company, that's fair, but it's only a fraction of the story. Today, Thomson Reuters is building the AI infrastructure that the professional world runs on. We serve over 500,000 customers, from the largest law firms and governments to startups and solo practitioners. We operate at a global scale with over 26,000 employees, 4,000 domain experts, and one of the world's largest trusted content ecosystems. And we're investing over $10 billion to transform how high-stakes work gets done. But here's the truth. Transformation is hard. Like many of you, we were wrestling with legacy code. For us, that meant decades of .NET applications. Critical to our business, but slowing us down and stacking up technical debt. We were asking ourselves the tough questions. Can we move faster without sacrificing trust? Can we modernize at scale, not just with one-off wins? That's why I'm here today, to share what we've learned as we take on one of our most ambitious migrations yet. It's not perfect, and it's not finished, but this is what it looks like when a 160-year-old company decides to move like a startup. Today, we support our customers by running over 70 digital products and managing more than 20 billion documents across legal, tax, and compliance workflows. But here's the challenge. That scale comes with complexity. We spent the last few years building an incredibly resilient, capable, global technology estate at Thomson Reuters. One of our major accomplishments is that we recently completed our migration of 95% of our workloads to the cloud. In total, over 50,000 servers across 1,000 applications in just 6 years. That move gave us a cleaner, more agile foundation to innovate on. It allows our teams to spend more time working on AI capabilities, but we were still carrying around the legacy .NET code, and that legacy was slowing us down. It wasn't just old, it was competing with innovation. Developers were stuck maintaining unfamiliar legacy frameworks that couldn't be replaced overnight. So we had to modernize while staying fully operational. That was our tension. So we started looking for AI technologies to help us solve this problem. We ended up choosing AWS. Why? For us, it came down to 3 things: reliability, intelligence, and velocity. We tested multiple modernization approaches. Some worked, but none were built to scale across hundreds of applications. When we got access to AWS Transform, we knew we had something different. It wasn't just another code converter. It was an agentic AI solution that could plan, refactor, validate, and iterate with our team in the loop. One of the first hurdles that AWS Transform solved was supporting the versions of .NET that we needed. Then, we ran into many other challenges. Some transformations started by skipping many of the solution files that we tried to transform. Some ran for days, needing us to re-authenticate just to keep them going. Some of them ended with hundreds or thousands of errors. But we kept iterating, we kept learning and working our way through each one, and it ended up with AWS Transform being the solution that generated fewer errors and handled them more gracefully. Documentation was thorough, clear, and designed for real-world use. And after we stumbled a few times, the success rate on transformations, especially the complex ones, was dramatically higher. We went from months of work to a 2-week sprint, modernizing 1.5 million lines of code each month. That's a 4 times improvement in speed. And more importantly, it gave our developers time back to build the future, not maintain the past. Now, we're modernizing for many reasons: speed, security, cost, and customer impact. Right now, we're running 7 .NET modernizations in parallel. That's millions of lines of code, not side projects. With Transform as a force multiplier, we're moving safely to production without shutting down or starting over. Because companies like ours don't get a greenfield reset, and these transformations don't happen in isolation. So what's the biggest win for our customers? Focus. Our engineers will be able to have the occasional sprint to merge and test upgrades instead of having a small number of resources always focused on that work. They can spend that time solving real customer problems, things that are specific to the legal, tax, and compliance professionals that we serve. It's also about quality and speed. Modern platforms let us ship features faster, adapt to market shifts, and deliver smoother, more integrated experiences across our products. But manual testing in some of these systems slows down how quickly we can validate these AI changes. From a business perspective, every modernization unlocks capacity. Less time on maintenance means more time shipping new features. It also unlocks years of IP in these code bases, allowing us to leverage it in new ways for our customers. And it reduces infrastructure costs. Moving to Linux cut operating costs for us by 30%. It dramatically reduced technical debt and eliminated risk by removing outdated dependencies. This all rolls up into one thing: greater agility. We can move faster, pivot when needed, and double down where we're finding traction. And we're not done, not even close. We have a handful of transformations done and thousands of .NET repositories to go. So we have a long road ahead, and we're realistic about what AI can and cannot do. This isn't a silver bullet, but that's true of all AI-assisted work. The value comes when you pair it with strong engineering practices. So we're expanding our use of AWS Transform beyond just .NET modernization, using it for ongoing hygiene and critical non-differentiating work. It's about removing friction so teams can focus on solving our customers' hardest problems with clarity and speed. So what did we learn? We learned to start small, then scale, keeping a core group of platform engineers involved to spread lessons learned from modernization to modernization. We learned not to wait for the perfect moment. You'll run into many issues, but your legacy tech won't update itself. We learned that AI isn't replacing your team, it's empowering them. We've been successful because we have the right team with the right skill set using these AI capabilities. Smart leaders understand the real win isn't just faster modernization, it's freeing up your engineers to do their best work. And we learned to make this part of your culture. When tools this powerful emerge, we must rethink how we work, embedding AI into our culture to unlock speed, scale, and smarter decisions. So let me leave you with this. We've learned that continuous modernization isn't a one-time project. It's a core capability. We're building a developer experience where undifferentiated work happens automatically. When a new version of a critical library is released, developers receive a ready-to-review pull request, minimizing time spent on routine updates. So make this automation part of how your organization works. Thank you.
All right, thanks, man. It's been exciting to see Thomson Reuters' journey and how AWS Transform is helping you all move even faster for your customers. So far, we have spoken about the innovative technologies needed to deliver on this vision of agents. But technology alone is not enough. It needs to be accessible. Achieving its maximal impact comes from enabling you and everybody to get started with it. Part of this is through professional services. We saw that many of you had been struggling to get from ideas from prototype to production due to lack of internal expertise. That's why 2 years ago, we formed Gen AI Innovation Center, which brings our global team of AI scientists, strategists, and engineers, and decades of internal expertise to you. Gen AI Innovation Center has been monumental in helping thousands of customers like Yahoo Finance, AstraZeneca, and Syngenta to move quickly to build AI-powered capabilities. And today, I'm thrilled to share that we are not just continuing this journey, we are dramatically accelerating it. We are investing in an additional $100 million in the AWS Gen AI Innovation Center, doubling down on our commitment to your success. The second area is education. AI will bring countless new opportunities and jobs that have not existed before. This is why we are launching a comprehensive program supporting early career professionals and college students, regardless of their major, to develop AI skills and literacy that employers are increasingly in demand. We have a goal to engage with 2.7 million young adults globally within the first year. And lastly, the best way to learn is by having fun. That's why today I'm excited to announce AWS AI League. If you have built Deep Racer, your own self-driving deep learning module in AWS Deep Racer, you can imagine this is like Deep Racer style gamification meeting the LLM world. With AWS AI League, anyone can learn, compete, and innovate in the ultimate AI showdown. You will gain hands-on experience while solving challenges for prompt engineering, model customization, with AWS services such as Amazon SageMaker AI and Amazon Bedrock. By sharpening these skills, you can further innovate and solve real-world problems. AI League kicks off today here at New York Summit at 3:15 p.m., where you can compete and win your ticket to reInvent 2025 and cash prizes at the reInvent finale. Good luck. To wrap things up, we have talked about how we think agents are impacting the world and how AWS is giving you all the tools you need to take advantage of this. Starting with Nova Ag, then services for getting agents into production with AgentCore, as well as a number of capabilities to make the most of with things like S3 Vector for your data foundation, Strands agents for building agents, and the AWS Knowledge MCP server for supercharging your developer agent. And of course, an entirely new set of agents on our own, like KIRO, and the strong impact of Q Developer and AWS Transform. And going beyond this technology, the things you need from AWS Marketplace, deeper investment in professional services, education, and making learning fun. We are still early days with agents, but with these innovations, we are charting the path to enable you to build the bright future we see ahead. Thank you, and enjoy the summit.